Let's play circuit sudoku. Your goal is to fill in this entire table. As is typically the strategy with sudoku, take what you know a lot about and try and fill in the one missing value. So let's find the resistance total. R1 and R2 are in series with R3 and R4, which are in parallel. So, substituting in all the values from the problem, total resistance 300 ohms. So now my strategy is going to be to find the I total. Let's analyze the circuit, figure out what's going on with current. I total is the current that exits the battery, flows through resistor 1 and resistor 2, then branches here and here. For simplicity's sake, I'm going to call this current I3 and this current I4 before finally coming back together and re-entering the battery. Total current. Remember that V equals IR. So I is V total divided by R total. Total voltage is the voltage of the circuit provided by the battery. The resistance total we just solved for. So 3 volts divided by 300 ohms, 0.01 amps. Based on my drawing, this total resistance flows through R1 and R2. So let's work our way this way to find the voltage drop across resistor 1. Remember that V equals IR. So what is the current flowing through R1? And the resistance value. The voltage drop across resistor 1, 0.01 times 100, is 1 volt. So I can take that back here, 1 volt. The voltage drop across resistor 2 is the current flowing through resistor 2 times the value of resistor 2. Resistor 2 and resistor 1 have the same current and resistance, so this will also be 1 volt. Where you go from here is a bit a matter of preference. I'll keep working my way down. Let's find the voltage drop across R3 and R4. R3 and R4 are in parallel. The voltage drop across these guys is the remaining voltage left from the battery after it dropped across 1 and 2. Let me show you. Voltage 3 and voltage 4 are the same value. Because of Kirchhoff's voltage law, we know that the sum of the voltages is going to be 0. So we have the total voltage put in by the battery minus the voltage removed from the circuit by resistor 1 minus the voltage from resistor 2 minus the voltage from 3 and 4. Because they're in parallel, the voltage drop will be just a single voltage drop. Okay. Solving for voltage 3 and 4. 3 minus 1 minus 1. It's 1 volt. Remember that these guys are really the same voltage drop. Okay, finally, let's find the current running through resistors 3 and 4. Resistors 3 and 4 have the same resistance value. They also have the same voltage drop, so the resistance will, the current will be the same. Okay, V equals IR. The voltage drop across resistor 3 we solved for just a moment ago. It was 1 volt. And the value of resistor 3, 200 ohms. 1 volt divided by 200 ohms. 0.005 amps. And remember that I4 will be the same. The table's complete. That's how you play circuit Sudoku.